This is lesson 12.5. In this lesson, we're going to be talking about line graphs, how to make them, and how to interpret them. So this is your yellow note sheet. Again, this is the last graph that we have to fill in. And so go ahead and open up the line graph section of that note sheet. And a line graph graphs how something changes over time. Fill that in. Changes over time. That is the big difference. And you will have line segments that are connected to make that line graph. So on the bottom, you should have the beginning of a line graph. So it looks like this. We are going to actually talk about the elements of a line graph. There is a title, either at the bottom or top. You have it at the bottom. And then we have the labels on each side. We have weeks. That is on the horizontal axis. That will always be related to time, usually. And then the thing that is being measured over time is on the y-axis, the vertical axis. So we're going to go ahead and fill in our scale. That's going to be something that we're going to have to do. So this is 1, 2, 3, and 4 weeks. Over a month's time, we're going to track the snowfall in inches. And we will have just a basic 0, 5, 10, 15, and 20 going up the y-axis. So again, we're kind of making up this data. So let's pretend that in week 1, there was 5 inches. Week 2, there was 15 inches. Week 3, there was 10. And week 4, we're back up to 15. Then we would take a straight edge and actually connect the dots. Notice I started here, not at the 0, 0 point. And that is one example of a line graph. Now I'm going to talk to you about a couple different types of line graphs. This one has the time in seconds on the x-axis, and then we are measuring the speed of something on the y-axis. And you can see that over time, the speed generally increases. That sloping upward line tells you that that vehicle or whatever is being measured is increasing in speed. So you can generalize or talk about trends by looking at line graphs. Here's a different kind of line graph. This is called a broken line graph. Similar to our example in our notes, it goes up and down. It varies. And so if we were to describe or interpret this, we would have to say, hey, between January and February, let's pretend that this is sales in a store. The sales dropped from January to February, but from February to April, the sales increased, and then they dropped again in May. So just pretending that that's the topic of this. This is a broken line graph. It goes up and down. Here's another broken line graph for you that has some context around it. We have years. Again, the time is on the bottom, and the number of students is over on the left. And over time, the participants in the science fair is increasing, but then decreasing, and then steadily increasing. And you would have to describe between 1999 and 2000, participation went up, and then from 2000 to 2001, it went down, and then from 2003, the trend, it seems to be going back up. This is a cool one. This is a double line graph. What you have here are games won by girls on a basketball team. That's the blue dotted line. And then we're contrasting and seeing during the same time period, how did the boys do? So we have the red line. These are both broken line graphs, but you can see and compare the two groups. This is another one that's interesting, and you can talk about trends more with this one. This is talking about foster care versus adoption over time. This is a little bit dated, but from 1995 all the way down to 2006 is the time frame. And then we have the number of children over here from 0 to 60,000. So if you notice, the adoption is the red line. That's generally going up. And then simultaneously, during the same time frame, the amount of kids in foster care is going down. And that would be expected as more people are adopting, less of the children are in foster care, instead they're in forever homes. So we could predict the future that this is continuing to increase and that this is continuing to decrease because of what we've noticed over this amount of time. We can predict what's going to happen in the future. So here again is the steps to make the line graph. Make sure you have the label that is, or the topic that is related to time on the horizontal axis, and the topic that is changing, either sales or population, number of children being adopted, that is on the vertical y-axis. You will have to establish appropriate scales. We'll talk about that. And then it's just plotting and connecting the dots. Make sure your graph has a title. And then we're going to talk about those generalizations. Is it steadily increasing? Is it steadily decreasing? And the other option is it goes up and down. It varies over time. So I want to talk briefly about a scale break. Sometimes you'll see this kind of zigzag. Sometimes it'll be a double line. These are not as readily used. And sometimes you'll see this wavy line. That all of those symbols indicate a break in the scale. Instead of having 0, 5, 10, 15, 20, 25, 30, maybe none of the data exists from 20 down. So to save space, what it really is a gap in the scale. Instead of going by fives, we're going to skip the 5, 10, 15, and we're just going to go from 0 to 20, and then 20 to 25, and 25 to 30. So you can see that from day 1 to day 7, the water temperature of a pool, perhaps, is going down, and then after a week, it starts to go up. Or it might be from water temperature in a pond or something. So this line break is something to pay attention to. You can use them, but be careful, and that lets you know that there is a break in the scale. So the last thing we have to talk about is how to predict the future. Line graphs are neat in the fact that they can actually talk about trends and patterns, and you can take that trend and pattern and extend it into the future. So you have to notice whether it's slanting upward or downward, and this will allow you to make that generalization, or what is the trend going in, which direction is it going in. This is the fancy word extrapolate that means extending the line, and it allows you to actually predict the future. So if you look at this example, this is the cost of tuition in a college, and this is graphing from 2002 all the way up to 2020. Obviously, that's in the future. So notice there is a scale break. It jumps from 0 all the way to 2002. Obviously, we don't want the data beyond 2002 for this example. And then you have the costs going in a straight scale, going from 0 to 2000 and then increments of 2000. So you can see the blue, solid blue line is the data, but then the red dotted line is that extrapolation or that extension of the line. So we have to kind of, I would take a ruler. In order to extrapolate the line, you would take a ruler, and in the general slope or the slant of the line, I would put my ruler on the actual data line and then extend it. That will give me the line that I need to actually pretend it's going to go in that direction. And then you can see where the dots fall, and I put a dot on this 2016 line, 2018 line, and 2020 line so that I can answer the question, well, what do you predict the tuition will be in 2020? We predict it'll be up to 12,000. Obviously, this is old data. This might not be accurate, but that is how you can predict what trends will be in the future. The last thing I will have is for you to try to make a line graph on your own and describe the change. That's simply saying, is the data increasing, decreasing, or if it's a broken line graph, telling me what intervals or what time frames it's increasing and which time frames it's decreasing. In this case, we're talking about weeks. So in what happened in week 1 to week 2, etc. If you want to check your answer, this is actually pulled from page 907 in your math book. It actually has an example of how you could explain that data on the line graph and has a picture of one. If you don't have any grid paper, you can just eyeball it, or you could make your own grid paper. Good luck, and I'll see you in the morning.